There's quite a lot of minor learning points in this question. So first of all, it's clearly a model. If you're ever given a model where there are no constants, you should always immediately plot it. So you must get good at this. You must never be satisfied unless a graph looks really immaculate on your screen, because you're going to copy it onto your page. This one, for example, some students just copy this. Hopeless. You must always press View Window, then Zoom Auto, then View Window again. Always. View Window. And then you say to yourself, what's sensible in this question? It's talking about time after a medication administration, so clearly it can't be negative. What's a sensible number of hours? We don't really know, but not many. I can easily change that. So 0 to 5. Then I go to Draw It, then Zoom Auto. Looks really nice, but you must then remember to press View Window again and go down to this one. Now, in this case, it is 0, but in many other cases, it'll be like a small number like that. And you go, all right, it's going from 1 to 200. Well, I'll make that 0 to 200. So good if 0, 0 is on the screen. That's the origin. I'm going to make that 300. And now I've got a really lovely diagram with the origin on the screen. I'm going to copy that down if I ever actually use it. But the first question says, find the rate of change. So the rate of change is just code for differentiate. So I'm going to differentiate this function. Dead easy. And you should be saying to yourself, right, well, I know the syllabus. It's either directly on the formula book, clearly not. Well, otherwise it is product rule, chain rule, or quotient rule. And that is crucial that you say the word product first. Is it a product rule before anything else? You will see that there is a chain rule in there, but it's a product rule first. So we must use the product rule. So 1000t is one of the functions and e to the minus is the other function. And we just do the simple product rule. We get that. So that's really nice. Find the rate of change. Notice I've used the correct notation. You'll see a lot of students writing dy by dx there. There are no y's and x's in this question. We could write dc by dt if you like. So that's really nice. Then it says, find the value of t when the rate of change of c is 0. So that means just put this equal to 0. And we're just going to do a solve n here. So that's trivial. However, let's just think about it. What does it mean that the rate of change is 0? What it means is it's a turning point. Let's go back to our diagram. It's a turning point. We could find it here. Just g solve maximum. That is the answer to this question. X equals 0.8. Yes, if you do solve n, you'll get 0.8 as well. But if you know both ways, it means you can check your answer. And it means you're understanding what's going on. Determine if the time found is a local minimum or maximum. Well, it's clearly a maximum, so I would sketch it as evidence of that. There's a variety of ways of justifying that, and I think a sketch is good enough. But another way would be to say, let's have a look at the gradient just to the left. So I'm going to find the gradient there by going to sketch, a tangent. Just to the left, it was 0.8, so I'll make it 0.6. And the gradient is 118, so that's positive. And then I will sketch a tangent at, say, 1, and it's negative. So it's got a positive on the right, on the left, and a negative on the right. Another way of doing it is, remember we had, this is c dash here. Well, the second derivative will tell you something about the type of turning point you're looking at. So let's differentiate this again. This time I'm actually going to factorize it before differentiating, because I've turned it into two functions being multiplied together, and I can use the product rule. And it's just a little bit quicker than doing the product rule here and then a differentiation there. So I've just got a product rule. Keep that one still, differentiate this function, negative 1250. Then keep that one still and differentiate this function. And we get that mess there. Now, if I put t equals 0.8 into that, I get that gradient, that second derivative. Now, if that is negative, that proves that it is a maximum. So you'd never actually do that in an exam, but it's good understanding and you have to understand it. The second derivative if you put an x value into it, in this case a t value, if it's negative, it shows it's a maximum. If it's positive, it shows it's a minimum. And if it's 0, it shows it's a point of inflection. Lastly, I'll just show you some advanced calculator use here. Here's my function. I'm going to plot the gradient of it. So I'll go to Options, Calculus. There's the gradient. I could type it in again, but it's in Variables, Graph Variables y1. And I want to plot it for all the x values. So I put x equals x in there. I draw that. Zoom Auto. Now, in this case, negatives do make sense, so I'm not going to go back in and change this -135. I want to see this little negative bit. This is really instructive, and you've got to get good at this. The blue one is the original function c. The red one is c dash, the rate of change of it. So here, c dash is equal to 0. It crosses the axis there, and that's indicating that there's a maximum at this point. Notice here that the gradient flattens out, and here the gradient of the gradient is 0. What is that? This x value here that looks to be about 1.5. What is that telling us about this point here? What can you tell me? It makes it that this one is a point of inflection. Here it's on the way down, and it looks like it's just going to keep coming down and down, down, but it doesn't. It then levels off, so it changes its concavity here from going down to curving to a plateau.